Hello and welcome to another FreeCAD tutorial. In this one we'll be making a design of a blower fan, which is modeled after a real piece that I've purchased, and the rationale behind this piece is I want to mount it to my 3D printer, so I have to design a mount for it, so it helps to design the actual parts to make an assembly later. So let's make this part first, so we can close the current document, make a new one, and I'll be using the parts design workbench mostly. I'll be using assembly 3 at the very end. If you don't have it, check it out. It's pretty cool. It's still in development, but it's very usable. So we'll be making two bodies. Okay, so the first one will be for the shell of the fan, and the other one will be for the part that spins. So let's make a sketch. This is a top view, so XY plane is correct. And so it helps to measure out the dimensions of the object beforehand. It will go much quicker, but of course, if you just do it as you go, that works too. So I'll start by making a rough shape of the top view of the fan, and then I'll add constraints as I go. So at its core, there's a circle which I want to be construction, and it's 50 millimeters in diameter, so 25 in radius. And then there's the actual nozzle where the air comes out, which I want to be horizontal, and it connects to the circle like this, vertical, and it is tangent to the circle, and it might be vertical. I'm not really sure. The out opening is, let's check my sheet, 18.8 in length. There we go. Can just move it a little bit. And there's the two little screw holes, which we have to do as well. So I'll just make little arcs like that, and semicircles that connect them. Okay, so now we can do the final arcs that connect everything. And this is gonna over constrain it a bit. It's all right, we can always delete some constraints later. So we have to delete 11. And that's it. Okay. No, it doesn't look right. I should be able to move these. Oh, I think I missed. Okay, let's just go back. So I'm hitting Control-Z to undo. And I think one of these two is redundant. Same for... So we got one here, this one can go, and this one can go too. So now we should be able to move, yeah, everything. So I'm not sure why it messed up. I mean, sometimes it does. Okay, so we have to input all the dimensions. So the radius here, I've just measured the screw holes, and they are designed for M4 screws, and the plastic is 1 millimeter thick. So that should have a radius of 3. This one should too. Oh, I did it wrong, so hit Ctrl-Z again. I'm going to select the two arcs and go for the radius constraint. And I will say, yes, I want the same radius of 3 millimeters. Also, these two screw holes are symmetric with regards to the center of the main circle. So I'll just make a asymmetric constraint. Okay, now all these 4 lines should be equal in length, and they should be parallel. Parallel, there we go. And of course, this they have to be one same line. So this point has to be, this point has to be on this line. And now that should give us everything somewhat constrained. We forgot one thing, which is around here, the circle should be tangent to the edge. So let's just add these. So one here, another here, but that's redundant somehow. Okay. Okay, looks like we only needed one. So now we have to input more dimensions. So from this point to the center of the thread hole, I measured 48.4. You can just drag constraints so I don't get in the way too much. So that's still not enough. We need to do 3 more measurements. So what's my second one? Oh yeah, the distance between the 2 screw holes. So let me just select these 2 points and these 2 only. And the distance is 53.6, but that's between the 2 edges of the circles, the 2 screw holes. So I'll need to add another 4 millimeters. So 1, 2, 3, 4, 57.6. So we need 2 more, or maybe just 1 more, I'm not sure. Oh yeah, 2 more. So I measured from this one to this one vertically. It's about, oh, I didn't write it down, I'll just redo it. It's about 45.4. So, okay, now it's saying only 1 degree of freedom, so we could do 1 more measurement, or we could just look at the shape and just say that, well, these 2 lines look to be more or less perpendicular, so let's make them so. Now the sketch turns to green, which means it's fully constrained, so we can close it. And we can pad it, which is just another way of saying extrude. And I've measured the height of the fan to be 14.8, but it might as well be 15. Okay, so as you've noticed, it's a solid object, and we need it to be hollow with a thickness. So I'll select the face that I want to make a hole out of, and I'll use this little guy, make a thick solid, which is weird because we're making it hollow, and it's not showing anything because it can't do it in its current settings. We just have to change make thickness inwards, and that does it. So the thickness we decided on, which is 1 millimeter, and that's what I've measured, goes on the inside, not the outside. And that's what the fan kind of looks like. So, okay. So we've almost finished this part. We just need to screw the 2 little holes here and add the main circle hole for the air intake. So let's start by doing the 2 little screws. So now I want to make a new sketch on this face. So I'll just select it and make a new sketch, and that's going to do it on this face. However, it's going to work for a part this simple, but when you make complicated parts with many, steps, and you're not sure about the final order of the final features, and if you still think that you're going to shuffle things around after, mapping sketches to faces like this is kind of dangerous, because let's say we change our sketch and there's 1 more face in the pad. Well, then this face, which is called face 13, is a new object. It might be this one. So the sketch would be mapped onto this face, and it would screw everything up. So what you can do is make a shape binder. So it doesn't really solve the problem of naming the face. We still have to name it. But if it later changes, we just have to go there and put the new face in there and it's going to work. So we won't have to change all the sketches. We just have to change this little guy. So we can hide the actual face and make a new sketch that's mapped on this shape binder. So now I need to somehow place a point, like make a circle, but I need to make it exactly positioned to right. So if only I could use the edges like this for constraints. Well, it turns out I can using this tool. So I just import external geometry on the sketch, and that just works. So now these 2 points should be coincident. And as I've said earlier, the screws are M4, so 2 millimeter. And let's do the same for the other one. All right. So we can hide the shape binder now. How do we make a hole with this sketch? Well, we use the pocket tool. And by default, it's only going 5 millimeters deep, so that's not enough to actually traverse both sides of the solid. So we could increase this dimension, but let's say we upgrade to a thicker fan later, we're going to have to change this value, which isn't really perfect. We can just do through all, and it's just going to remove matter indefinitely going down. So that's what we want here, and that worked. So now we have 2 screw holes. And we only need to make the center hole for the air intake. So I'm again going to need to map a sketch on this face, but I don't really mind that these holes are here or not. So I can reuse the same shape binder. And that's the beauty of it. You can reuse the shape binder. So if later the reference changes, you don't have to redo it in every sketch just one time. That's much better. But again, on a part this simple, it's not really that much of a deal. So let's map a new sketch. I'm going to need to access these 2 points again, so I'm going to import them. And I am going to need a construction line connecting the two. And the center of the air intake is actually not centered with the fan itself. It's a little bit offset. So I'll make the circle first, and we'll position it just after. It's like this, and I've measured the distance between these 2 points to be, and again, I forgot to write it, so that's all right. (27 millimeters). So it's almost at the center, but not exactly. And the air intake itself has a diameter of 31.2, and because I'm lazy and I don't want to divide that by 2, I'll just type divided by 2 and it's going to work. So there we have it. We just have to make another pocket, so I'll just show that and hide the shape binder. Oh, and by the way, I'm just tapping the spacebar to show and hide objects. So let's make a new pocket, and this time we actually only need 1 millimeter. Because this is only 1 millimeter thick, and we only need to cut the first, the top, not the bottom. The bottom is supposed to be full like that. So that's it. This part is done. So we can now move on to the new part, which is the little blades that go inside and that spin. So I'm going to hide this part. And you'll notice that this body is like lightly blue background colored, which means it's active. So if I click any of these buttons, it's going to want to do it on this body. And now I want to switch to this one. So I just double click it, and now it's the active one. So let's start by making a new sketch on the XY plane. And this part is a bit easier. It's just a flat circle with a disc on top and a few blades. So I've measured this one to be, and again, I don't think I wrote it. It's all right. Yeah, we can Let's just put 20. It doesn't really matter if it's off by a millimeter or two. We're not going to see it anyway. So, okay, now we just have to pad it 1 millimeter. And now I want to make the space for the actual electronics and magnets of the motor that go inside. I'm not going to design those. I don't need to go that far. So again, I need to map a sketch to this face, and I could do it directly, but I prefer making a shapebinder object and mapping a sketch to it instead. And the main area for the motor itself is 24.2 in diameter, so I divide by 2 for the radius, 12.1. And now we can just pad it. 10 millimeter. Okay, let's see how that looks. Yeah, that's about right. You can always change it later. And now we just need to do the blades. So again, I'm gonna need to map a sketch on this face, the torus-shaped face. But because I'm only gonna touch the edge, I can reuse again the old shapebinder. That's not gonna matter. Oh, I messed it up, so I click on the face first, then new sketch. So the blade looks like... actually, I just want to reuse the circle there, so... And we'll make a little rectangle. Like this. Well, it's not going to be a rectangle, but this point should be on the circle too. These two sides should have equal length. These two sides should have equal length too, and now we just have to decide on a thickness. We can just... So the thickness is a distance between this point and this line orthogonally. Let's say we want about 0.8 millimeters. This looks about all right. No, it's a bit too... Let's try this. So let's pad it. 10 is all right. And now we want, obviously, to make many blades that go all around. So what we want to do is use the polar pattern feature. So I'm going to select the feature I want to mirror, which is this pad, and go into the polar pattern. And by default, it's only going to make 2, but I want 30. It's taking a bit of time. And there we go, we have it. We have all our 30 blades. And by default, it's going to use the normal sketch axis, which means when we are seeing the sketch flat, it's the axis that's coming towards us, the viewer, which is almost always the z-axis, which is what we want in this case. So let's click OK. And the piece is done. So now we have the two pieces, but you'll notice that they don't fit. So that's where the assembly workbench is going to come real handy when we have multiple pieces that we want to, well, connect. We have many tools that make the job very easy. So I'll switch to the assembly workbench. And this isn't strictly necessary, but I'll make 2 assemblies and just drag each part into its own assembly. This isn't really necessary, but I found that it's almost better to make bottom assembly with only one part. That way, if you want to change the part later, you don't have to redo all the constraints. You just have to go to the assembly, change this part, and tweak the elements here. And it's going to work in the other assemblies as well. You won't have to redo everything. So it means you can still change pieces like the shape after they've been assembled, which is a really cool feature. So we want to assemble the new. Oh, and I can now give meaningful names. So let's name this one blades, and let's name this one shell. So I'm going to make an assembly with these 2 parts. So you've noticed that we have access to a ton of new constraints here. So one of the first constraints you almost always want to do is a lock constraint, which means a part that really shouldn't move. And here, I don't think the body should move. We just want the inside part to fit correctly. The outside shouldn't move, so I'll just lock it in place. And now, well, we want this circle, well, this disk and this circle to be aligned on the same plane coincident. So I'll just make a plane coincident constraint and let's try solving it. But before that, I should probably save the document because, well, this is still an experimental feature and sometimes the solver kind of crashes the whole program. So we'll just make we'll just name it fan. And let's try solving the constraints. It worked. So the two planes are now coincident, but you see that the part is too high. We want to offset it a little bit down, and we can do that by going to the constraint, this one, plane coincident. So you can see we still have these two things, and we can just change here the offset. Let's say 1 millimeter. Let's resolve. And that's too high, so let's go -1. That's still a bit too high. Let's go -2. And that's just perfect. And now the piece is correctly aligned. So we could go a bit further and model screws and assemble them as well in the holes. And you can do it very easily with the tools I've just demonstrated while making the fan. So this might be a cool exercise to make a screw and put it in the hole with the assembly workbench and the part design workbench. All right, so thank you for following this little video. I hope you found it useful. I hope you found it easy to follow. And I'm eager to hear about your feedback. See you next time.